A stone is thrown from top of a building upward at an angle of 30° to the horizontal with an initial speed of 20 meter per second as shown. Okay, I should be giving the diagram. Anyways, you guys can draw it yourself. So if I happen to throw a stone at this angle with the velocity of 20 meter per second at an angle of 30° with a height of 45 meters. So we need to figure out the range and time of journey if I'm right. How long does it take? Is it take the stone to reach the ground? Okay. What is the speed of the stone just before it strikes the ground? So I have answers over here. Again, no idea if it's right or wrong. So we can start with the working. So I'll start labeling things because it helps. So when the object reaches the same height, I'm going to call it as point P. And when it reaches the ground, the point where it reaches the ground, I'll call it as point C. Okay, so we can describe that also. So let me do a bit of organized manner. So this is an horizontal line. And here the object will reach with a speed of 20 meter per second. This is from a property that we have studied, and this is 30°. So when an object reaches the same height at the other side, it will have the same velocity and the angle magnitude will be the same, just that it will be in the negative direction. If this is positive, this is negative. Okay, so we'll call it as let point A represent point of throw. Again, I'm keeping the language simple. You just have to communicate point P as the same height and it's where the object passes on its journey down. And point C, point on the ground, where the object hits, falls, or strikes the ground. Okay, so with all of this, now I start with the working. So this would be a normal scenario for you guys. We have it going up, coming down, so on and so forth. All that is okay. So now we'll talk about journey from A to B. So how long does it take for the stone to, so we can figure out the time. Actually, just a second. This will come later. The same part, actually, it's the same question itself. So we'll answer later. Let me go back. Yeah. So journey from A to B. Again, I don't know the formula. I will do my work. So the first is I will consider the vector, then resolve it. Resolve it along the x and y component. This is 30°. So this will be 20 cos 30. And this is 20 sine 30. So this will be 10 meter per second. This is 10 root 3 basically, right? This is 10 root 3 if you guys want to write it off. 10 root 3 meter per second. Okay, so next is we will start off with your y component. So for that, I would consider the initial velocity along the y is 10 meter per second. Acceleration due to gravity is minus 10 meter per second square. Okay, so g would be so. And we have right hand up as positive direction. And so making this as negative. Then what else? Our time of journey will be t by 2 for or at maximum height. So basically I can go with final velocity at the maximum height will be 0. With this I'll be able to find t by 2, right? So I can use v is equal to u plus at. So final velocity is 0, initial velocity is 10. This is 10 into 1 by 2. So this is 5 and so 2 seconds. So within 2 seconds, yeah, I'm able to reach that peak. Okay. So next I can find the height. We need to figure out the height, is it? How long does it take for the stone to reach? So time we found, we don't need to find the height. We don't write what is the speed of the stone just before it strikes the ground. Okay, done. So we know the time of journey from, this is by the way from A to B. So that's why I wrote all of that. This is from A to B. This is not a time of journey for the entire journey. This is from A to B. Okay, then what else? Then we can go with journey from B to C. So for this we have y components. So that is v o y is equal to, so now we are pointing down. So still it would be the same, just that it's minus 10 meter per second. Then we have, then we have the height. We know the height, the distance it will travel. It will travel 45 meters. Then we know g, and what else? I think this is good enough. So I can use s is equal to ut plus half at square to figure out the time of journey. V square is equal to, we don't know the final velocity, so we have to make use of this. And here the time will be time of flight from B to C. That will be the time. So we have S is equal to ut plus half at square. So this is 45. This is u is 10 into tb. Oh, sorry, minus 10. It's pointing downwards. And this is also pointing downwards. All are negative actually. Okay, so this being 0, this is pointing downwards, right? And we are considering down as negative. Actually, we can go part by part, but let me not confuse you guys. T square. So this would be 5, and 5 is common everywhere. 5 ones are, 5 twos are, 5 nines are. A bit of rearranging and we have TBC. And we have TBC square plus 2TBC minus 9 is equal to 0. Can we resolve this? 3 3s are, how is this possible? Okay, let's see if I have a solution for this. Okay, so we do have answer for this. Just that I'm not able to show it to you guys now, the calculation that is. It's around 2.16 second. That's the time of the fall. So total time will be sum of those two, TAB and TBC thingy. So we need to know the final impact. So for final impact, we just need to know the final velocity. So we know the time of journey. We can find the final velocity. So Vy from B to C. We know V is equal to U plus. So Vy at point B, AT. Okay, so this is Vy BC is equal to, see, we already know the horizontal component, is it not? When it impacts, when it hits over here, we already know the horizontal component. How much is that? Same as this, 10 root 3. Now we are trying to figure out the vertical component. So with this too, we'll be able to figure out the resulting. What is the speed? We just have to find the speed. So this would be, this we know, this is at Y, it is 10. And this is minus, oh sorry, this is minus 10, this is minus 10 into 2.16. So this will be minus 3.16 meter per second, indicating it is, oh sorry, 31.6, indicating it's pointing downwards. And finally, we have V at C in terms of magnitude is equal to root of 31.6 square plus 10 root of 3 square root. So again, you don't have to calculate all of this. You should not be getting such numbers. 31.6 square plus 100 into 3. So this is 1298. Root of 1298. It's around 36. Okay, meter per second. So I'm doing this just for the sake of checking if the answer is right. I've written some numbers over here. Oh, it's right. Oh yeah, time of journey I forgot. 2 plus, that you guys can complete now. 2 plus 2.16, that is 4.16. 4.16 and 4.22. That is a bit off. And by the way, acceleration due to gravity is 10. Maybe this is 9.8. Okay, see, all these questions are meant to work out with calculator. So don't be baffled with the numbers that how is this practical. It is meant for calculator, using calculator, working with calculator. It's supposed to be that itself. So this was a complex question. We traditionally had a look at, or we have what if questions also. Traditionally, we looked at questions like this, right? Or throwing an object in this manner. Now we looked at this actually. What I did was I divided it in two parts. This is the first journey. And from here to here is the second journey. From A to B is the first journey and B to C is the second journey. Right? And again, I use the same concept, horizontal and vertical components. I dealt with it separately. See, horizontal component has nothing. It's just a constant stuff happening. Everything works out from your vertical component. How high does it go? What is the acceleration due to gravity? And so on and so forth. So depending on that, the horizontal will play a role. So always start off with vertical scenarios because that is the key. So you don't have to remember any formula. I don't remember any formula. I don't have to. Even competitive exam questions, yes, I understand that there you need to memorize. But to that point, you don't memorize anything. Say a month or 2 or 3, or maybe not month, but 3 or 4 months before your actual exams like that, then you can memorize. Then you can apply it and get familiar with it and so on and so forth. Till then, you keep understanding the concept, keep deriving it with every question. That's the best way forward. Right? Okay, what if the horizontal wind is blowing in the same direction as the ball is thrown? It causes the ball to have a horizontal acceleration of this. What part of the this example A or B will have a different answer? Yeah, this is something that you guys have to answer. You threw, it went and fell, right? They're asking what component of this journey changes. Provided you have a wind which is going to accelerate the object with this value. Simple. The time of journey, will it change? No, because this particular value is not dealing with the horizontal component. So the time of journey remains same. So what changes? Height, does it change? The maximum height, that too remains same. So basically what happens over here? Simple common sense, ball will get pushed forward and it will go further away. So the range will change. Range will be more. Okay guys, actually even this can be calculated and we can find the difference. All you have to do is consider the acceleration. We know the time. Where is it? Is this it? No, not that. We didn't find the range for this. Anyways, it's quite simple actually. So we just use S is equal to ut plus half at square and you're done. Time will not change. It has an accelerated value. Just substitute things over there and you're done. Okay. So we can pause and have a look.